Okay, fifth graders, 8-4. I hope this isn't glitchy like yesterday's was. I'm not sure what happened with that. I restarted my tablet. Everything looks fine. Checked all the settings, so I'm not sure what could be wrong. So I'll go over this one. I'll try to go over it pretty quick here because I want to check to make sure it's not acting up. Anyways, chapter 8, section 4, talking about modeling when you multiply fractions, and this is what they're doing here. So I'm looking at the first one here. It says there was a quarter pan of lasagna left, and Tom ate 1/3 of that quarter that was left. So I mean, you can see that this would be about a quarter here. So here would be another piece, and here would be another piece, and here would be another. So this would be 1/4, 2/4, and 3/4, and 4/4 here if the whole thing was there. But so there's 1/4 left, and then you would divide that 1/4 into thirds, and so that's kind of what they do here in B. They're showing you that, and so each one of these right here represents a quarter. So there's 1/4. Here's another quarter, and then another quarter. Notice that each one of the quarters is divided up into thirds, and he ate 1/3 of that. So then you just simply see how many parts are there. Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12, and so it's 1/12 that he ate. Okay, 1/4 of a third would be 1/12. And then you could actually just do it right here. Do 1/3 times 1/4. 1 times 1 is 1. 3 times 4 is 12. And so what do you get? You get 1/12. Here's another way to look at it. And I'm looking at section C here. They drew a grid, and they shaded one of the 3 rows yellow to represent 1/3. So this right here represents 1/3. And then they shaded one of the 4 columns, because each of the 4 columns represents a quarter. So here's a quarter, and here's a quarter, and there's 4 quarters in a whole. And then what overlaps? You can see it right here. And so that's another visual way to look at it. So, and if those help, that's great. So let's look at the convince me really quick. We can do that one together. It says find 1/4 times 5, and it says using the model to explain your work. Well, so let's represent, let's see here. Find 1/4 times 5. So here's, let's highlight a quarter right here. This is a quarter. All right, and there's 3 other quarters that I have not highlighted. So I'm not worried about this one, I'm not worried about this one, I'm not worried about this one. I'm just highlighting 1/4. Okay, you can see that. And then I'm going to highlight 1/5. All right, so here's 1/5 highlighted right here. There's 1/5 highlighted. I'm not worried about the other fifths. I'm only highlighting 1/5. I'm not worried about this one, this one, this one, the other. Those I'm not worried about. I just highlighted 1/5, and I highlighted 1/4. And so what do we have right here that kind of that overlaps? It's that one right there. And so let me point out to you, I could write down 1/4 times 1/5. And you guys know that's going to equal 1/20. Notice that in the model we have here, how many little squares do we have? Well, there's 20. And how many overlap in what we've highlighted? Just 1. Okay. All right. Let's see here. Let's move down a little bit further. Another example. Let's see here, 2/3 times 3/4 using a number line. Well, let's just do this here. I'm just going to put down 2/3 times 3/4. I mean, you can look at their example if you want. This one comes into play because it does some cross-canceling that's kind of convenient. And I'm going to do this 2 different ways, because there's different ways you can solve some of these things. So can we do any cross-canceling? Okay, let's look at this one, the 3 and the 3 here. You bet. How many times is there a number that goes into both of them? Evenly? Yeah, 3 does. 3 goes into 3 once. 3 goes into 3 once. All right? How about 2 and 4? Is there a number that goes into 2 and 4 evenly? You know, so there's nothing left over? Yeah, 2 goes into 2 once. 2 goes into 4 twice. Now we just multiply straight across. All right, what do we get? Did I write this down right? What am I looking at? I'm looking at the other example. Yeah. So 1 times 1 is 1, and 1 times 2 is 2. So it's a half. So 2/3 times 3/4 is 1/2. Now let's do it the other way here, where we wouldn't even do any cross canceling. I'm going to show you 2/3 times 3/4. I'm not even going to bother with cross canceling. What's 2 times 3? That's 6. What's 3 times 4? That's 12. Can I reduce 6/12 to something? Yeah, 6 goes into 6 once. 6 goes into 12 twice. Look at that. We get the same answer. The cross-canceling really helps when you've got some larger numbers that you're having to deal with. It can make it a lot easier. But either way, you're going to come up with the right answer, assuming your sums and additions and your products and all that are correct. All right, so number 1, it says use the model in box C on page 346 to find 2/3 times 2/4. All right. I'm not worried about the model. I'll just put down, find 2/3 times 2/4. You guys could do that. Create a story problem. Not interested. Thank you. Number 3, find 5/6 times 1/2 and shade the model to help solve. Okay, so find 5/6 times 1/2. So how many in one row here? How many do we have here? We have 1, 2, 3, 4, 5, 6. So we got to shade 5/6 of those. So so 5/6 of this whole piece here would be all of this. Okay, so there's 5/6 of the whole shaded. All right. Now it says to shade half of it. Okay, so I'm going to shade half of it. And so I'm just shading half of it here. All right, that didn't come out really well, but you can kind of see what's going on here. So let's see here. I'm trying to think the best way to show you guys. So let's go ahead and do number 3 over here. 5/6 times 1/2. Can we do any cross canceling? It doesn't look like it, so let's just multiply straight across. 5 times 1 is 5. 6 times 2 is 12. So the answer is 5/12. I'm going to put that right here, 5/12. And this is what I want you guys to see. Take a look at this here for a moment. How many of the boxes within the hole are shaded with both colors? 5 of them, and it's these first 5 right here, and that's where you get the 5/12. Okay. All right. Yeah, I'll leave that at that. 3/4 of 4/9. Okay. Now this phrasing, find 3/4 of 4/9. All that means is 3/4 times 4/9. So whenever you see a problem that says 3/4 of and then something else, That of means you're multiplying. Okay, the of means the same thing. Of equals, I'm just going to put it in parentheses, multiplying. I'll put a little X there for multiplying. So don't let those confuse you. All right, I got to wrap this up here. I'm taking too long because I didn't want to make this a long one. I'm afraid it's going to be glitchy again. I'm looking really quick here. Let's see here. Find each product and shade the model to help solve. So I'm looking at number 5. 1/3 times 5/6. Okay. So here's the 5/6. 1, 2, 3, 4, 5, 6. So 5/6 would be these right here. Okay. That'd be 5/6. And you could look at it this way. Let's divide each one of these into thirds. Okay. So I'm gonna draw another little line, and I'll use a thin little red line. Okay. So this first one right here is now in thirds. This one right here, this is what I'm talking about right here, this one. I just divided that into thirds. You can see it's 3 parts. Okay? And so this one's now in thirds, this one's in thirds, this one's in thirds, this one's in thirds, this one's in thirds, although we're not really worried about that one. And it's 1/3 times 5/6. So I could shade 1/3 of each one. This is just another way to look at it, if it kind of clicks with you guys. Notice I didn't, oh wait, no, I should do one more. Okay. 1/3 of 5/6. 1, 2, 3, so 1, 2, 3, 4, 5, 6, 1, 2, oh, I did one too many. Okay. So, notice how many are shaded there. How many do we have shaded? There's 5 of them. So let's go over here and do this. What's 1/3 times 5/6? Well, 1 times 5 is 5. 3 times 6 is 18. 5/18. If you counted, you'll see that there's 18 individual little squares or portions or parts, and I've shaded 5 of them in blue. Okay. All right, let's see here. Let me do this one. 2/3. All right, 2/3 times 1/12. All right, so I'm going to shade 2/3 of this. So there's 2/3 of it shaded. All right, because here's a 1/3 right there. There's another 1/3. So here's 1/3, here's 2/3, here's 3/3. All right, so that's divided up into thirds. Just wanted to show you that. And I've shaded 2/3 of it. And then it's 1/12 of 2/3. So now I'm going to shade 1/12 of it. So just one of these little rows right there, because it's just one. All right? And so we could come over here and write 2/3 times 1/12. Can we do any cross-canceling? We sure can. 2 goes into 2 once. 2 goes into 12 6 times. Can't do any more cross-canceling, so 1 times 1 is 1. 3 times 6 is 18. So it's 1/18. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right. Yeah, we'll leave that at that. All right. Okay, I think you guys can do the rest of these. You don't have to use models. If they help you understand this, that's great. If they don't, then don't worry about it. Just go ahead and solve those. The problem solving, let's look at that really quick. Then this video ended up being a lot longer than I had hoped. Make sense and persevere. Will $50 be enough to buy 6 cans of paint? There's the price of each can, so 6 times that. See if you have enough money. Number 16, a scientist had 3/4 of a bottle of a solution and she used 1/6 of the solution in the experiment. How much of the bottle did she use? So what are we doing? We're multiplying 3/4 times 1/6. And I see some cross-canceling you could do. Number 17, what value of n makes the equation true? 2/3 times n equals 4/9. Okay, 2/3 times n equals 4/9. Well, let's see here. Think about this. 2/3 times something equals 4/9. What times 2 equals 4? What times 3 equals 9? Well, 2 times 2 equals 4, and 3 times 3 equals 9. There you go. So it's 2/3. Number 18, write an expression that shows 10 to the 4th. Well, it's going to be 10 times 10 times 10 times 10, 4 times. Number 19, plumber charges $45 for the first hour and $30 for each additional hour. How much does he charge if it takes him 4 hours to make a repair? I'll see if you guys can figure that one out. Number 20, if 7/8 is multiplied by 4/5, will the product be greater than either of the two factors? No. Anytime you multiply something by a fraction, that is a fraction less than 1, it's going to be smaller than whatever you're multiplying by. So you can put that in your own words. And I'll say it again, anytime you multiply a number by a fraction that's less than 1, then the product will be less than what you were multiplying by. Right? And I have to say a fraction less than 1, because there's some fractions that are greater than 1, like 7/6. That's greater than 1. How do I know that? Well, 6 goes into 7 once. What's left over? 1/6. So 7/6 is the same as 1 and 1/6. That's greater than 1. So you can't just say a fraction. You have to say a fraction greater than 1. 21, 22. You guys can do those. All right, that's it. I'm going to end the video, and I'll see you later.